Okay. Okay, now we're recording. Okay, here we go. So I'm going to first show you the announcements. I decided instead of writing them here, the announcements are all on MathBreeze. I want to get you used to looking at MathBreeze for announcements, so I'm going to just put that up for a second. Okay, so here the announcements are right here on the side. Okay, so we have, first of all, we're continuing to record class sessions. We have a new assignment due 016. That's the absolute value assignment. So that's due on Monday, April 6th. And tonight we have 015B due. That's the inequalities. Okay, that's inequalities, polynomial and rational inequalities. Okay, so those are the assignments. All right, so let me get back. So here, this is the important one, 016. One thing I didn't mark here and I should put up is that we do have an office hour tomorrow. So I'll just write that. I'll just write that on the whiteboard. Okay, so let me go back. Okay. All right, so we're going to have a WebEx office hour. So that's tomorrow, 9 to 10. It's for all my classes. Okay, and this is the number that you need to get in to join. It's always the same number. 822-465. Okay, so I'll try to keep up these office hours. If somebody wants a different time, if someone can't make it, just send me an email and we can set up another time. Okay, so here's what we were doing. We were looking at equations and inequalities involving absolute values. So I just want to review a couple of equations. So here's one type where we have absolute value equal to absolute value. All the ones with equal signs were pretty much done the same way, except that when we have absolute value equal to something not an absolute value, this is the case where we have to check. All right, so let's do this one. Like I said, they're all done the same way. We end up with two equations. All right, so here we have one equation would be x plus 1 equal to 1 minus 2x. And the second equation is x plus 1 equal to the negative of the right-hand side. So either they're equal or one is equal to the negative of the other. And we just solve and we get two solutions. Okay. So here if we subtract 1 from both sides, we get x is equal to minus 2x. Let's say we add 2x to both sides. We have 3x equal 0. See, if we add 2x here, we're going to get 0 on this side. Okay, and then divide by 3, we have x equals 0 is one solution. All right, here, open parentheses, x plus 1 equal minus 1, and then minus minus would be plus 2x. All right, and subtract x from both sides, and we have, I'll just put that in. So we have 1 equal minus 1 plus x, and then add 1 to both sides, and we have x equal 2. So those are our two solutions. All right, so now let's look at the second one, and this is the one that we have to check. Okay, so this is of this form. Something with x is an absolute value equal to some expression not an absolute value. So this is the one that you must check. And you should understand what could go wrong. If we plug x into this side, we might get a negative. That's what could go wrong. Notice this is almost the same equation that I wrote up here. I just removed the absolute value from the right. So we're going to be solving the same exact equations. All right, so we're going to have the two sides equal to each other. And we're going to have one equal to the negative of the other. This is the same thing I wrote down before. So I won't continue solving this because we just did it up here. This one is x equal 2. And this one we solved already. And we got x equals 0. But now we'll check. All right, so let's check. Substitute 0 into here. And we have 0 plus 1. We have absolute value of 1 equal to 1 minus 0. So basically 1 equal 1, so that one checks. And here, let's do this check. We're checking x equal 2, plugging back into the original. So we have 2 plus 1, we have 3 over there, is equal to 1 minus 2 times 2, 1 minus 4. So here we have 3, absolute value of 3, which is 3, is equal to 1 minus 4, or 3 equal to minus 3. All right, so that one, this one does not check. And we end up with just one solution, x equals 0. Okay. All right, so we just started doing inequalities. So let's remember what we were up to. Okay, we said, so let's look at the inequalities. All right, so we said if we have something like this, absolute value of x, this time I'll do less than or equal to 5. So we want to ask ourselves, what numbers does that include? All right, what numbers have absolute value less than or equal to 5? Okay, so certainly 5, 4, 3, 2, 1, and things in between as well, something like, let's say 4.5. Okay, 0, that's also 0 has absolute value less than or equal to 5. Or so does minus 1. Okay, the absolute value of minus 1 is 1, which is less than or equal to 5. And we can include minus 2, minus 3, minus 4. Again, if you have absolute value of minus 4, you have 4, which is less than or equal to 5. Okay, and we can go all the way up to minus 5, and things in between as well, but not beyond. Like minus 6 wouldn't work. That's it. So it's minus 5 to 5, basically. So this includes everything from minus 5 to 5. So it's very important to understand this example. Okay, so this means numbers between minus 5 and 5, and we can open it up like this. So if you understand this one little example, then you can do all the problems that involve absolute value less than or equal to a number. Okay, all right, so for example, let's say we have 2x plus 1 less than or equal to 7, then that means that this will be between 7 and minus 7. All right, so we just write it like this. And solve it the way we did in the previous section. All right, solve these. We already solved these double inequalities. We subtract 1 from 3 sides. So we want to basically isolate x in the middle. And divide by 2. All right, so we have x, and we have less than or equal to 3 and greater than or equal to minus 4. Okay. All right, so like I said, basic example, just remember this is the same as this double inequality. Okay, and then you'll be able to do these examples. Okay. All right, I'm going to get a new board here. I'm going to open up a new one, just one second. Let me just get a new one. Okay. All right, let me give you one like this to do. Like I said, they're all pretty much the same. All right, so let's do one. This time we'll have, say, we could do this. Just to make it a little bit different, you have to start by isolating that absolute value. All right, so in other words, just bring the -5 over to the right as 5. Okay, and then continue from there. So you do this one. And you can write in the answer in the chat. Okay, that looks good. I'm not sure if it's the same on both sides. Let me just try. Okay. All right. Okay. All right. That looks good. Right. It's going to be different on the two sides. All right. So let's do that. So let's put the 2x minus 1 in the middle. Oh, let me first start by rewriting it. Bringing the 5 over, that is. Let me start with that. Okay, so we want to isolate the absolute value and then put the 2x minus 1 in the middle. Put 5 on the right, minus 5 on the left. Okay, then add 1. All right, 2x. So here we have 6. And here we have minus 4. And then we're ready to divide. Okay, minus 2, 3. Okay, yeah, so here we have to be careful. When you add 1, you get the minus 4 here. And this is the solution from minus 2 to 3. Okay, so those are the basic less thans. That's how we do the less than. And the greater than, so they're just the opposite. Let's look at the greater than. Again, we're going to use as a model for these, we're going to do absolute value of x. Let's say we'll do greater than or equal to 5. So we use that as a model for how to do all of them. So if we understand this, then we'll understand how to do the greater than. Okay, so we just want to say what numbers have absolute value greater than or equal to 5. Is 100 in here? So just type yes or no. Right, definitely yes, right? The absolute value of 100, definitely bigger than 5. So what about minus 100? Is that in there? Yes or no? Okay, good. Right, because you put that in, minus 100 in there, and you get 100, which is greater than or equal to 5. So that's certainly in there. Okay, what about, okay, 3? No, right? That's not, the absolute value is not greater than or equal to 5. Minus 3, also slap on the absolute value, and you get 3, and it's not greater than or equal to 5. Right. What about minus 5? Is that in there? What do you say to minus? Yeah, minus 5 is. It's actually equal to, the absolute value of minus 5 is equal to 5, so that's good. Minus 6 is good. So basically, it's going to be everything to the right of 5 and to the left of minus 5. Let's do the number line now. Okay. It's going to include 5, certainly include 5 and numbers bigger than 5. And on the other side, it's going to include minus 5 and numbers to the left. Okay, like in here somewhere we have like minus 100. All right. So opening this up, we would say x less than or equal to minus 5, or x greater than or equal to 5. So this gives us things on the right, all the way on the right, going to infinity, a piece of the number line on the right, and a piece of the number line on the left going to minus infinity. Okay. So if you understand this example, then you could do all the examples. I'd like to do one practical example. All right, so let's say we want to somehow express extreme temperatures. Well, by extreme temperatures, I mean extremely hot or extremely cold. Okay, so it's better to express this in terms of Celsius. Okay, so the Celsius temperature, let's say if it's greater than, let's say, 30 degrees Celsius. All right, so what would that mean? That means the temperature is more than 30 degrees, and that this is very hot. All right, 30 degrees Celsius is, I think it's like high 90s. Okay, so that's very hot. Or this means the temperature is less than minus 30 degrees. Okay, and that's very cold. Okay, that's something like minus 25 degrees Fahrenheit, something like that. Okay, so this is how you could express an extreme temperature. If the absolute value of the temperature, we're talking about Celsius, it works better with Celsius. If the absolute value of the temperature is greater than 30 degrees, so we have something on the right, like extreme hot, I'd say on the right, or extreme cold on the left of the number line. You understand this example? So that's one practical example using this notation, this absolute value notation. Okay. Okay, so let's do an example. Okay, I'm going to get a blank board, another blank board. We'll start with a simple example. All right. So this means that 2x plus 1 might be less than minus 7 on the left, or 2x plus 1 is greater than 7, that's on the right. Okay, left of the number line, right of the number line. So when we have something like this, the answer is always going to be, okay, this one's greater than, so I'm using round. It's going to be always here and here. I just have to fill in what these are, this one and this one. So we'll fill that in a second. But the answer always looks like this, a piece on the right and a piece on the left. Okay, so let's just fill this in. So subtract 1. And we have 2x less than minus 8. And divide by 2. And we have x less than minus 4. So the less than part, that's here. So we can fill that one in. Okay, and let's do this one, subtract 1. Okay, divide by 2. X greater than 3. So the right-hand side is from 3 and on to infinity. The left-hand side from minus 4 to minus infinity. Okay, so we can write it like this. You can write or union. Okay, so let me give you one like this to do. Okay, let's say we do a greater than or equal to 10. Okay, so you do this one. Okay, anyone have anything? All right, I'm gonna open it up. Okay, 3x minus 2. This is the left piece, less than or equal to minus 10, and then the right piece is that. Okay, so just remember this one always opens into two separate ones. Okay, and now let's just solve these. And now divide by 3. Okay, that's the less than side, so that's this one. This one's going to be minus 8 over 3. And now let's do the greater than, that'll be this one. Okay, add 2. And now divide by 3. So that's the right-hand side. Okay, so this goes down to minus infinity, this goes to infinity. Okay, this has an or in between. So we can write it like this. Sorry, square bracket here. All right, so do you understand this type? You want to just type in, tell me if you're understanding this, how to open these, the greater than. Do you want to see another example? Should we do another one? Okay, so let's do another one. Okay. Okay. All right, another greater one. Okay, so let's say let's just do a simple one, okay? Let's just do absolute value of x minus 3 greater than 5. Okay. So we have two sides. All right, this is going to be to the right of 5 and to the left of minus 5. All right, left, I'll do the left first. This is the left. It's going to be less than minus 5. And then the right side. Okay, like that. All right. And then we just solve this. Okay, so it means x less than minus 2 or x is greater than 8. Okay. So it looks like this. This is the left piece. And this is the right piece. Okay, this goes. It's nice to do it on the number line because that translates well to the intervals. So for the intervals, just looking at this, we would have minus infinity minus 2 together with 8 infinity. Okay. Okay, so does everyone see the difference between, how to open the greater than and how to open the less than? They're sort of opposites of one another. Okay. Just remember the greater than has two separate pieces, right, left. And the less than has one piece in the middle. One piece of the number line, that is, in the middle. So that really finishes this chapter. Let me just look at the homework from 016 to make sure that you could do all this. Okay, just looking at the homework. Yeah, I think we did everything. All right, so I have 016 due on Monday, so I think you're ready to do that. You're ready to do on 016. So we're going to go on. All right. I think, by the way, I'll announce it later. We're going to have a quiz next week because I want to practice using the Blackboard multiple choice quizzes. So, before we do the test. So next week sometime we'll have a quiz. All right, maybe Tuesday, but I'll tell you exactly what's going to be on the quiz, and just a few questions, maybe 5 questions, just to get used to using. Just want to make sure everything works well with Blackboard so we can get ready for our test, which will be after the spring break. But I want to do a little quiz before the spring break. All right. Okay. So let's go on to the next chapter. So we're starting a new topic, which is basically graphing. Chapter 2 has a lot of graphing in it, and we'll start with something familiar. We'll talk about the coordinate plane. Okay, so everybody knows what the coordinate plane looks like. Maybe I'll use the line here. Okay. We have an x-axis, a y-axis. The origin 0 is in the middle. Okay, we have 4 quadrants. This is quadrant 1. It's important to know the names of the quadrants. Quadrant 3, quadrant 4. Okay. And if we want to locate a point, let's say in quadrant 2, let's say we want to locate a point that's to the left 3 and maybe up 2. To the left 3, that would be have x coordinate -3, and up 2 would have y coordinate 2. And of course we list x first. So this is the point -3, 2. All right. So x gives us the right left direction and 2 gives us the up down direction. Okay, in other words, x is right left and y is up down. Okay, so we're going to start with looking at the distance formula, and we'll see where the distance formula comes from. Okay, so let's first, let me get to a line again. I'm going to draw just the first quadrant, because that's all we'll need in this example. Okay, so we're looking at the distance formula. All right, so let's say we have the following point. Let's say we have, this is 2 along the x and 1 along the y-axis. So this is the point 2, 1. All right, let's look at another point. This is 1, 2, 3, 4, 5. Okay, 6 along the x, and here 1, 2, 3, 4 along the y. So let's look at this point as well. And we want to measure the distance between those 2 points. Okay, so let's suppose we don't know the distance formula. One thing we could do is draw a straight line coming down here. Okay, and let's do that. And have it meet with a horizontal line coming from the first point. So this is a vertical, this is a horizontal. So we get a right triangle when we do that. All right. Now we want to find the hypotenuse, the length of the hypotenuse. Well, we could find the length of the 2 sides. That we could do without a distance formula, because we can see what it is. This goes from height 1 to height 4, right? 1 to 4. This is, you can see along the y-axis, this is 1, and this is height 4. So this is 4 minus 1. And here, this length goes from x value to the right 6 and to the left 2. So the length of the horizontal line would be 6 minus 2. I'm writing it in this subtracted form, okay, just so we can build up to the distance formula. So if we have a right triangle and we know the two sides of the right triangle and we want to find the hypotenuse, we can use the Pythagorean theorem. All right, so Pythagorean theorem, a squared plus b squared equals c squared. So in this case, let's say this is our A. Doesn't matter which is A and which is B. Let's say this is our A and this is our B. And this would be our C. The hypotenuse is the C. Okay, so we have, but I'm going to call the hypotenuse D for distance. All right. Okay, so square the first side. So we have 6 minus 2 squared. And the second side, 4 minus 1 squared, equal the distance squared. So if we take the square root of both sides, and I'm going to write D on this side now, then this is the distance. All right, what is 6 minus 2? Well, 6 minus 2 is basically it's just the x coordinates subtracted. You see, 6 minus 2, those are the x coordinates. And 4 minus 1, those are the y coordinates subtracted. Okay. So the general distance formula looks like this. If you have, this is for distance between points. All right, I'm going to call them x1, y1 for the first point. Like, let's say this would be x1, y1, and x2, y2 for the second point. So to get the distance, we just subtract the x values. Doesn't matter which one we put first, but I'll put x2 first. In parentheses squared, and subtract the y values. That's like what we did up here. So we see that from this example, that this is the general way of finding the distance between 2 points. So in general, we won't be graphing the points like we did here. We'll just substitute into the distance formula. All right, let's just finish this one. We might as well figure that out. Okay, so what do we have here? This 6 minus 2 is 4. 4 squared is 16. So here we have square root 16. And here 4 minus 1 is 3 squared, and we get 9. So this is square root 25, or 5. All right, so in this case, the distance is 5. This side is 3, 4 minus 1. This side is 4, and this side is 5. So you see this is a 3, 4, 5 right triangle. Okay, let's just practice using the distance formula. Okay, so we're looking at this formula, and let's say we want to find distance between. Let's say 1, 2, and 5, 6. We're just going to subtract the x's and subtract the y's. Now I like to line up my points like this vertically, because the biggest mistake people make is they will subtract an x and a y instead of subtracting 2 x's. So if we line them up, here we have the x here and we have the y here. You see they're lined up. So let's subtract the x's first. Let's say these. And subtract the y's. We have them lined up. Okay, and let's just figure this out. So here we have 4 squared, we have a 16. And 6 minus 2 is 4 again, so another 16. Square root 32. We could simplify this. All right, maybe we'll just simplify that. This is 16 times 2. And if we take the square root of 16, we have 4. Okay, I'll give you one to do now. And just write in the distance when you finish. This time you're going to have to be careful with signs. I'm going to throw in some negatives. Okay, so you set this up. I like to, rather than writing out the formula each time, I just put the square root and those parentheses squared like that, and then I just fill in. Okay, subtract x's, subtract y's, and like I said, be careful now with your signs. Okay, when you have an answer, then please just write it in. Okay, anyone get an answer? Okay, I'm going to line up the points. Okay, then I'm going to subtract the x's. So here we have to be careful. It's 4 minus minus 2. And subtract the y's, minus 7 minus 3. Okay, this 4 minus minus 2, that's 4 plus 2. Okay, I just wrote it underneath. So, okay, that looks, all right, that looks good. Let's see what we have. Okay, here, this is going to be 6 squared, so we'll have a 36. Okay, this is a minus 10, and we're squaring it, so we have 100. Okay, so I'm getting the square root of 136. Did anyone get this? Square root 136? Okay. Okay, great. So that's the distance formula. And let me just, well, I'll just give you one more to do quickly, okay? Just any points. Again, I like to put in some negatives. Okay, there we have a lot of negatives in there. All right, I'll line them up. Okay, so you do this. It doesn't really matter which one we put on top, but I just always put the second one on top to be consistent. Okay, so I'll do this one. So let's say, okay, all right, let's try that. Okay, I'm glad you're getting these. So minus 1, subtract minus 4, two negatives here. Okay, and minus 2 minus 5. So this one, minus minus 4, it's minus 1 plus 4. And this one's minus 7 in parentheses. Okay, so we have, this is 3 squared. So that'll be a 9. Minus 7 squared, so that's 49. Okay, good. So I'm glad you're getting this. Square root 58. Okay. This section, 2.1, just really basically just has two formulas in it, distance formula and midpoint formula. So I'd like to do the midpoint as well. So I'm going to erase this, and we'll do one last formula. Okay, and that'll be it for today. Okay, so let me just erase this. Okay. I can get rid of this. 1 second. Okay. So we're doing midpoint formula. Okay. So we'll start with a straight line. I like to start with a straight line when I do the midpoint formula. And we're just going to get the midpoint between 2 points on the line. Okay. So let's say this is 2. And let's say this is 8. All right. So if I just put all the notches in between 2 and 8, okay, so we have 2, 3, 4. Wait, let me just do it a little bit better, a little more even. Okay, so that's 3, 4, 5, 6, 7, 8. So you can just look at it and you can see this is in the middle, right? 5 is in the middle. That's the midpoint. We have 3 units to the left and 3 units to the right. So that's the midpoint. All right, let's say we had something that we can't really, place the notches in between. All right, it'd be too much. Let's say we had -2 and let's say 102. So we want to know this middle point. Okay. What calculation can we use to get the middle point? Any idea what that middle point is? All right. Well, what we do is the middle point is simply the average. If you add this up, if you add 102 plus -2 and divide by 2. It's just the average of the 2 points. All right. So that's 100 divided by 2, 50. So 50 here is the middle point. Here 5, also it's the average, 8 plus 2 divided by 2. All right. If you had grades, let's say you had some grades like 2 grades, 80 and 90, your average is 85 right in the middle. All right. So that's how we find the midpoint on a number line, and the midpoint in the coordinate plane is going to be very similar. So let's just, we'll put it down here. Here in the coordinate plane, I don't like that line. I'll use my line here. Okay. If we have 2 points, let's just call them the first one x1, y1, and the second one x2, y2, and connect them. So we're looking for this point in the middle. And it's going to be, it's a point, right? So draw open and close parenthesis, and we're just going to do averaging again. You average the x's, add them up, divide by 2, and average the y's. Just like on the number line, but we do it twice. So if you remember the averaging, then you'll remember the midpoint formula. It's a pretty simple formula. Let's just do a simple example. Midpoint between 1, 2, and let's say 5, 7. Okay. So okay, remember it's a point. So always do this first. And start like this, divide by 2, divide by 2. So fill in that blank that blank pair of numbers like that. Start like that. And then just take your x's and your y's. Again, it's good to line up your points so that we match up the x's and the y's. It doesn't matter which is on top, which is on bottom. Okay, so here we have our x's. Make sure you put the x's first, and make sure you put the y's second. And that's it basically. Just this is 6 over 2, 3, and this is 9 over 2, so we just leave it like that. So the midpoint formula, pretty simple, just a matter of remembering it, really. All right? Okay. All right, so I'll just give you one to do. So let's do -3, 5. Okay, so you do that one. I'm going to set it up. And I'm going to line up. Okay, so here we have -7, -3. Those are the x's. Okay, add these, and add the second one, -2 plus 5. So this is -10 over 2. That's a -5. Okay, great. And 3 over 2. All right, so this section really, 2.1, just contains these two formulas, distance formula, midpoint formula. So so we finished that. The homework assignment in this section, I think, is just 2 questions, one distance, one midpoint. All right, but we're going to be continuing with this next time. So let me just remind you, office hour tomorrow. I put that up somewhere. Let me put it up. I'll just write it over here, the office hour. So that's Thursday, 9 to 10 on WebEx. And I'll give you that number. It's always the same number. And I should always have office hours at this time. And if you want to make an appointment for a different time, send me an email if you can't make it. Okay? And then we had the other announcements. Okay, I'll give you a chance to copy the number. And then I want you to get used to looking at Math Breeze for announcements. Okay? Because I put them up there on the left. Okay, so let's just look at this. Here are the Math Breeze announcements. We're recording our class sessions and putting them up. 016 is due Monday, and 015B is due tonight. Okay, so those are the most important announcements, and you can always, like I said, always check Math Breeze for those announcements. Okay. All right, so I think we'll end here. And hope you have a nice rest of the day. Okay, let's see. Do we have to hand in the review? Oh, there. Okay, right. There's a review up. No, I'm going to be probably revising the review to the exam because it's going to be a little bit, I'll see, I didn't make up the exam yet. So you don't have to hand that in. We'll be going over some of that, but you don't have to hand it in. We're going to have a quiz next week. I hope the quiz will be Tuesday. Maybe we'll do a quiz on Tuesday. I think that would be good. All right, just to practice using Blackboard, the Blackboard quiz, the Blackboard test feature. Okay, I want to practice using that. Yeah, and exam 1 is going to be on Blackboard. That's really the only way we have pretty much of giving the exams. I mean, I could put up something on MathBreeze, but the Blackboard format is a little bit better for tests. So I think we'll do it there. Okay, any other questions? All right, so yeah, it's going to be multiple choice. The Blackboard exams we don't really have any other way of doing this, so it'll have to be multiple choice. The quiz also multiple choice. I just want to practice using the Blackboard test feature, so it'll be the same. Like maybe 5 questions, multiple choice, something like that. Yeah, on Blackboard. It's just really to practice using it to get everybody ready for taking the test. Okay. Yeah, MathBreeze, I know you're used to MathBreeze, all right? So it's maybe easier for you to do it on MathBreeze, but this is like something that the math department wants. They want us to use Blackboard, okay? First of all, the questions are given in a mixed up order, and they just would prefer that we use it like that. We do MathBreeze, that we do Blackboard. So for me, MathBreeze is easier, but I think I'm gonna stick with Blackboard for exams. Okay. Any other questions? Anyway, we'll be practicing it before the test, so everyone should know how to use it. Okay. So let's say Tuesday, quiz on Tuesday, let's say, and I'll tell you exactly what's on it. Okay, I'll I'll certainly tell you on Monday or send out an email before that. And check the MathBreeze announcements as well. Okay. Okay, so I think we'll end here, and hope you have a good rest of the day. Okay, and have a good weekend. Okay. All right. So let me close this.